Section 3.4 is really just a continuation of 3.3. We're going to look more at conditionals. We're definitely looking at them from a different perspective in this section, though. There's no truth tables that we're going to be working with. We're looking at creating the other kinds of statements that are related to truth, to conditional statements. So let me get started with one. A conditional statement, as you know, is a statement that is written in if-then form, P implies Q. This is the same definition that we had in the last section. And what we're going to look at in this section is finding the converse, the inverse, and the contrapositive of those statements. So if P implies Q is our original statement, what the converse does is it flips the order around. So instead of saying if P then Q, it says if Q then P. This is not the same statement we started with. You flip it around and it is something different. The second one leaves the order the same, inverses. Q and P, they stay where they originally were, but you negate each of them. It's not P implies not Q. And the last one reverses both, contrapositives. So it switches the order and it negates them. So now you have the negation of Q implies the negation of P. And there are equivalencies among these different statements. In particular, statements and their contrapositives are equivalent. And we'll do some examples so you can see why that works. But these are equivalent statements. They sound a little bit different, but they mean the same thing. And converses and inverses are also equivalent statements. Again, they sound a little bit different, but they mean the same thing. So what I'm going to do right now is I'm going to pause the discussion and I'm going to show you a quick video. Are you ready? Silly songs with Larry. There must be something wrong with his logic, right? Clearly, there was something wrong with his logic. So we're going to examine a few of the different kinds of converse, inverse, contrapositive statements and do them, and you can see when we're going to get these equivalencies and when we're not. Okay? We're not doing monkeys and apes, by the way, but we'll do some other ones. So for each of the given statements, we're going to write the converse, the inverse, and the contrapositive, all in if-then form. And then we're going to talk about why it makes sense that certain ones of them are equivalences according to the fact that they should be, right? It says that they should be here in this table. We're just going to verify that from a contextual standpoint for our examples. All right, if you love God, you will obey his commands. So this is John 14:15. I don't remember which version it is, but we're going to write the converse, the inverse, and a contrapositive. And again, it doesn't have the word then in there, so if you prefer to write it in, feel free to do the then right here. And you will find that we're probably going to have to change some verbs around to make things sort of flow and make sense from sentences perspectives, and that sometimes that happens with these, and it's okay. So the first one says you love God. And the second one says, you will obey his commands. Those are the two statements, correct? Okay. What does the converse do with these statements? It switches them, okay? We're just going to switch the order. The if stays at the beginning, the then stays in the end. Don't move the if and the then around. They're not moving, okay? So we're starting with converse, and we're starting with the word if. So instead of having if you love God at the beginning, it has if you obey his commands. That's the beginning part. Then, what will it say next? Then you love God. We'll talk about equivalencies in a second. Let's just get the three written down first. Inverse. What do I do for the inverse? Okay. If you do not love God, then, right, then you will not obey his commands. And then the last one, the contrapositive. Okay, so for the contrapositive, how is it going to start after the word if? If you do not, and you could feel free to change the word him to God at the beginning or something like that if it's more structurally like pleasing to you. But if you do not obey his commands, then what? Then you do not love God. Okay, so these are the three of them we're supposed to create. We did that. According to what this table told us, a couple of these are the same. The original statement and the contrapositive, that's the last one we did. And then the other two are equivalent to one another. So these two are sort of grouped together, and these two are grouped together. So let's just talk real quick about these. The first one says, if you love God, then you will obey his commands. The contrapositive says, if you don't obey his commands, then you do not love God. Does it make sense to you that those are the same statement? Those are the same statement. That's exactly what we mean, and we do use this in English all the time. Same's true for the middle two, the converse and the inverse. If you obey his commands, then you love God. And if you do not love God, then you will not obey his commands. Both of those are the same statement. It's easiest to read it probably from the converse perspective. The converse perspective is exactly the rule follower who has no relationship with the Lord, right? You're just following the rules. You're just following the rules. So that doesn't mean you love God. You can do it with your parents too, can't you? You can. You can show no love and still follow the rules. All right, so the two in the middle, converse and inverse, are the same statement, written differently, and then so are the contrapositive in the original one. All right, this is a good example of one where it's not written in if-then form. So the directions here at the beginning said it may be helpful or necessary to rewrite the statement in if-then form to start. That would be directed at this statement. This would be much like our statement about shopaholics in the last section. Right, shopaholics have no self-control. We had to write it in if-then form. So our form, like what I write and what you write, might look a little bit different, but they'll be pretty similar enough to do this. It won't be a problem. We're going to take milk contains calcium and turn it into an if-then statement. What might you write to change this into an if-then statement? Sure, that'd work. If it is milk, then it contains calcium. Okay, so this is a really easy one to do because you can talk about food labels, right? Okay, so we'll look at the equivalencies after this one as well, but let's write all three of them down first. So this is the original statement. Now we're ready to do the converse. What is the converse going to be for this? If it contains calcium, hang on. Then it is milk. What would our inverse be? Good. If it is not milk, then it does not contain calcium. And what would my contrapositive be? If it does not contain calcium, then it is not milk. Okay, so imagine you're just looking at a food label, right? Calcium is one of the things that's recorded on a food label all the time. There's a few cases where it might not be, but in general, it's going to be on there, just like the calories are going to be on there, right? So it's going to say if it has any calcium to speak of in there. So if you look on the food label, don't know what the object is. I'm thinking about this last one. And it says there's no calcium in it. You know that's not milk, correct? Right? There's no way that is a milk, that it is milk if it does not have calcium in it. But what happens if you look on the food label and it says it contains calcium? Do you know for sure it's milk? Nope. What could it be? Something else. Does anybody know? Orange juice. That's the first one I was thinking of too. It could be almond milk, which is absolutely not milk either, by the way. We have it in our house. I mean, we use it, but it's not milk. That's the only reason one of my Ethiopian daughters will even touch the thing. The whole idea grosses her out. You don't drink milk where she's from as a thing. It's not a thing. It could be yogurt, right? It could be some certain kind of granola bars. It could be broccoli. Do you know broccoli has calcium in it? Yep. It's not always an added-in thing. Broccoli does too. So there's lots of things that are in this category of converse and inverse here in the middle, right, where it's not milk and it does have calcium. The label says it has calcium and it's not milk. These are the same thing. But again, if it's milk, it's going to have calcium on the label. And if it doesn't have calcium on the label, then it is not milk. Are we good? Okay. The next one is actually one where we're changing the language around in symbol form. Okay? So the symbols don't start out P arrow Q. The symbol actually starts out negation of P arrow Q. But we're doing the same thing that we were on the previous ones. It just doesn't have the context to it. Converse does what to the statements? It switches them. So Q will come to the beginning, tilde P will come to the end, and the arrow remains between. What does inverse do? It negates both of them. So instead at the beginning of having tilde P, I'll have P. I'm sorry. Yeah, P. And then instead at the end of having Q, I'll have tilde Q, or not Q, right? And then my contrapositive does both, right? So I'm going to switch the order and I'm going to negate them. So how does it start out? Tilde Q, and then it will end in P. Negates and changes the order. Okay, we're going to work a little bit more on this if-then translation. So I want to give you a non-exhaustive, that means it's not complete, list of different things that could be changed into if-then statements. Some of them we're not going to see very often. Some of them we'll see frequently. Some of them are just sort of hit and miss. Some of them you'll never see for what we're doing. But they are all statements that mean P implies Q. So one is if P then Q, and the other one is if P Q. So we've seen those a lot. These are the ones that are the majority of the ones we see and that we've worked with. You've also heard me say P implies Q quite a bit. So these are very common. The last one over here, we saw happen last time where I had to actually move the order of something. The if showed up in the middle and it got moved. We saw a variation of this one earlier, all P or Q. The word all wasn't in it, but it said shopaholics have no self-control. If you said all shopaholics have no self-control, that's the same thing, right? So we saw a variation of that. The last three are ones that we haven't discussed. The two that are above, the orange one I just highlighted, we will not see in our work to speak of. You could see it in my math lab problem, but nobody's ever mentioned to me that they have been confused by seeing it or anything like that. But they are equivalent. It says P is sufficient for Q. It means it's enough. It's enough for the thing to happen next, right? If I score an 89.2 on the test, then I will have an A. It's enough. It's sufficient. If I flip the order around and say necessary, Q is necessary for P, right? It's necessary for it to happen. And the one that's the most awkward one, I think, is probably the P only if Q. Because it looks a lot like that one, except for the word only. And what only does is it changes the order, is what it really does. So I mentioned earlier that we're not going to move the ifs away from what they're connected to, and this is the time when we do. This is the exception. Okay? P only if Q means if P then Q. That's what it means. And I believe we have an example. Yes, number 5 is an example of this happening. So we'll see it happen in context here in a moment. So we're going to take each of our statements and we're going to rewrite them in if-then form. Again, the context structure of our language might look a little different from person to person, but what will happen inside of my math lab is they'll be given in multiple choice. So you don't need to worry about, do I change that verb or not? They're going to change it or they're going to not. It doesn't matter. You'll be able to identify it from there, okay? So the first one we have is all whole numbers are integers. This one's a lot like the shopaholics have no self-control and milk contains calcium. How would I rewrite this in if-then form? If it is a whole number, then it is an integer. Which happens to be a true statement too. We did that last chapter when we were looking at our boxes inside of boxes in the real number system. Ready for another one? Okay, this is a tricky one because it's got the only if. The principal will hire more teachers only if the school board approves. Okay, so only if means the if is going to move to the beginning, but nothing else is changing in the order. It's the only if that moves, and we drop the only. So if the principal, and this is where I'm going to change the verbs, if the principal hires more teachers, then the school board approves. Yes?
Could you not switch that around to be if the school board approves, then the principal hire more teachers? Or does that not work?
It doesn't work. The only if moves the if to the beginning. If we change the order around as well, then we've changed it into this statement over here. And the order changed by having the if without the only. So let's think about this. And I think this one's still hard to think about, even with the context, but we're going to try and reason through it. It says the principal will hire more teachers only if the school board approves. What that means is if the principal hires more teachers, then the school board does approve. Okay? It doesn't mean that the school board is forcing the principal to do it. It just means that if the principal did it, it's because he was allowed to. Can you see that? It's a little bit of a different statement, right? If somebody votes to hire more people, but then they don't hire more people, that's okay, right? They were allowed to, but they just didn't. That's what this is saying. This is the weirdest one. The next one's kind of funny just because of the words that are there. So this is a mathematical statement, but it says the square of a 2-digit number whose units digit is 5 will end in 25. So let me just tell you what it's saying first because it sounds funny. It's just saying if you have a number like 15 or 25 or 35 or 45, right? Take any of those numbers that end in 5. Squaring them means multiplying by themselves, right? It means that the number you get when you square it now will end in the number 25. Okay? You all right with that? Okay. So like 15 times 15 is 625. The 25 shows up then. That's all it's saying. All right, now let's actually do what the directions say, which is to rewrite it in if-then form. So it's going to start out if. If what?
If the square of a 2-digit number is 25.
Okay. Not quite.
If the 2-digit number
Uh-huh.
whose units digit is 5, then the square will
Yeah, it's kind of weird just because of the math part of it. So if a two-digit number ends in 5, or you could say whose unit digit ends in 5, then the square will end in 25. I have another version of this. Let me just write it down so you have another version of this here too that mimics maybe the ordering a little bit more closely, but it doesn't sound as nice. If a number is a square of a two-digit number ending in 5, then it will end in 25. Mimics the language a little bit better from where it started, but it's a little bit more confusing to read.